everyone, welcome back. It's Miss Grace. Today we are going to learn how to solve powers with fractional exponents. So essentially we're going to look at different numbers who have fractional exponents, and in this particular case we're going to look at ones that have a numerator of 1 in the exponent. So for example, if we have something, any number, so even say this is 5, I'm just going to let A represent any number, and then that's raised to a power of 1 over any other number. Could be a half, could be a third. The main thing you need to know is that the number on the top will remain a power, and the number on the top actually becomes the index of a radical. So we actually need to change this into, say, a square root or a cube root. So this will become the index of your radical. So let me just show you an example. So say if I have 9 and I'm raising that to the power of a half. Because I have a fractional exponent, initially I know that I'm going to have some type of radical, some type of root. So the number on the bottom here tells me what needs to go outside my radical. So this tells me that it's a square root. And remember, if we have a square root, that is assumed that the index is 2. So technically, I don't need to put that 2 there. I can just leave it as the square root sign because it's assumed that that's 2, okay? But if you want to put the 2 there, you can. The base goes underneath that root sign. So I'm essentially getting the square root of 9, and then I'm raising 9 to the power of 1, which is just 9. So once again, whenever you have a numerator of 1 here, you can almost just ignore that and just use your bottom number to tell you if it's a square root or a cube root, etc. Okay? So because of this, I need to now calculate the square root of 9, and we know that that's 3, and then that would be your answer. Okay, so we have another example. What if I have 27 to the power of 1 over 3? So once again, because I have a fractional exponent, I know I'm going to need to get some type of root or radical, and the bottom number here tells me that this is a cube root. Because my numerator is 1, I'm just going to ignore it and not put it as a power, because 27 to the power of 1 is just 27. But if you want to write that, you can. So essentially, I just like to tell my students that if you see something to the power of 1/2, it just means a square root. And if you see something to the power of 1/3, it just means a cube root. And the cube root of 27 is 3. So that would be your final answer. Okay? So these are key ones to remember. Anything to the power of 1/2 is square root, and anything to the power of 1/3 is a cube root. Similarly, anything that is under a square root can be raised back to the power of 1/2, and anything with a index of 3 can bring back to a power of 1/3, okay? So let's just do a couple quick examples. This is just asking us to write as a radical or revert it back to a fractional exponent. We don't need to solve it. So for example, this one says 10 to the power of 1/2. So since it's a power of 1/2, I know it's a square root, so I'm essentially just writing it as the square root of 10. You can put a 2 outside as your index if you want, but not required to do that because it's assumed, right? Now we're going backwards. This is a square root of 3. So remember, if we're getting the square root of something, that's the index of 2 here. So this is the same as 3 raised to the power of 1/2, right? Anything that's a square root is raised to the power of 1/2. Anything that is a cube root, for example, is raised to the power of 1/3. So if we see here, we have a cube root. So this means that 4 would be raised to the power of 1/3, or to the 1 over 3. And now 5 to the 1/3, this tells me it's a cube root, so I have a root sign with 3 as my index, and then 5 is underneath that root sign. Okay, so that's if we just need to go back and forth. So the key point here is that anything that has an index of 2 here, so say this is any number, that's raised to the power of 1/2. And anything that is a cube root, that's raised to the power of 1/3. Cool, so those are interchangeable. So what if we have situations where we actually need to solve for the particular power? So let's do a couple of those. So I'm just going to do the first few here. we have 81 to the power of a half. So remember, if something is raised to the power of a half, it just means square root, index of 2 here. So I'm getting the square root of 81, and we know that that's 9, so that would be your answer. Okay. I'm going to jump down and do this one down here because it has a fraction. So we have the square root, we have 4 over 9 raised to the power of a half. A half means square root, right? So I'm going to take everything underneath or inside this bracket here, and I'm going to put that to a square root. So whenever you have a fraction raised to the fraction, just put it all under the root sign. And then when you have a fraction raised to the power of a half and we convert it into its square root, you're just going to treat the top and bottom separately. So I'm going to take the square root of the top separate and then also get the square root of the bottom separately. So the square root of the top, square root of 4 is 2, and the square root of 9 is 3. So that would just be my answer, 2 over 3. Okay, so whenever you have a fraction raised to the exponent, just treat the top and bottom separate. Okay, so now we've looked at examples where we have the numerator of 1. So essentially you're just either calculating the square root of a number or you're calculating the cube root of a number. But what happens if my numerator is not 1? What if I have a number raised to the power of a full-on fraction without a numerator of 1. So for example, it could be 5 to the power of 2 over 3. So it could look like that. How am I going to solve that? Well, similarly to before, this number still serves as what the index is of that root. Okay, so the 3 here that's on the bottom of my fraction still becomes the index of my square root, and my 5 would still go under here. The only difference is now we have a power that is not 1, so I have to include it. So what we do is you put a bracket around the whole radical, and when you get this answer, we raise that to the power of 2. Okay, so the denominator of your fraction is still the index of your root, tells you if it's a cube root or a square root, etc. And the top number, your numerator, becomes an exponent. Okay, so essentially we have the bottom number becomes your index, and the numerator, the top number, becomes the power or stays a power outside. Okay, so let's do a couple of examples. Now they're telling us to full-on evaluate. So the first thing I'm going to have to do is to convert it into some type of root, and then I'll solve it after. So I have 27 to the power of 4 over 3. So initially I have a denominator of 3, so that tells me that I'm getting a cube root. So I'm going to put 3 as an index, put my 27 under the root sign. Now this 4, this numerator here, that becomes my power outside a bracket. So do that last. Do whatever is inside the root first, or inside the bracket, and then raise it to the exponent afterwards. Okay, so if I'm going to get the answer for this, I'm going to evaluate what's in the bracket first. The root, so the cubed root of 27 is 3, but then I still have it raised to the power of 4 here. And remember, this is the same as 3 times 3 times 3 times 3. You don't have to write that, but that's where we get it. It's not 3 times 4. It's 3 times itself, times itself, times itself. And if we plug that into a calculator, you would get 81 as your answer. Okay? Okay, let's do another example. So we have 9 to the power of 3 over 2. So right off the bat, I have a denominator of 2. That tells me I'm calculating the square root of 9. You can put a 2 here, but remember you don't have to because it's assumed when we have a square root that the index is 2. So it's up to you. And then we need to raise all of it to the power of 3, and we'll do that at the end. Okay? So I'm going to solve what's under here first. The square root of 9 is 3, and then I'm going to raise that to the power of 3. So remember, this is the same as 3 times 3 times 3, and that would give me 27. So that would be your answer for that. Okay? Does that make sense? Okay, let's do one more. we'll do a fraction. Okay, so if I look at this one here, I have 1 over 9, and it's raised to the power of 3 over 2. So once again, if we have a fraction, don't worry about it. We're going to treat the top and the bottom separately. But the first thing I'm going to get you to do is notice if it's a square root or a cube root. What am I going to put as the index of my radical? It's a square root, so I'm not going to put the 2 there. And remember, just take the whole fraction and put it underneath that root sign. Okay, so I'm technically getting the square root of 1 over 9. And because my numerator is a 3, that is going to go outside a bracket. And once I solve this inside, I will raise that number to the power of 3 at the end. So as I mentioned before, whenever we have a fraction underneath a root sign, just treat the top and the bottom separate. So I'm going to get the square root of 1 and the square root of 9 separately. And then I still need to raise it to the power of 3, and I'll do that at the end. So the square root of 1 is 1, and the square root of 9 is 3. So now I've solved what's inside, but I now need to raise it to the power of 3. So just to review with this type of problem, if I have a fraction raised to a power, all I need to do is raise the top number to that power and the bottom number to that power. So I'm essentially going 1 to the power of 3, 3 to the power of 3. Okay? 1 to the power of 3 is just 1, and 3 to the power of 3 is 27. So my final answer would be 1 over 27. Okay? Hopefully that helps. Thanks for watching.